I didn't change anything, only I'm explaining more. And then 1.2 to F1, then I'll connect here. Now I don't have this type, right? But because it is there, this is, it doesn't matter. And this one here to the negative. Now we are going to connect, this is the terminal. We are going to connect the voltmeter across. We are here now, we finished this one.
Here.
Now here we are going to connect it. Please, just a minute. We have U2, U1, it doesn't matter. Is that okay? You can change them. It doesn't matter, just make sure it is between two lines.
Yes.
Right? Don't worry about the label because this is AC. So what we do, two lines.
All right.
I need what? Two different colors. Now here we have long colors, long one and short one. If I look at this one, I know that I have yellow, blue, red. In some of the table it's different because of limitation. Now if I use this wire to connect this one, it is waste. You see it? It is waste. Look at this one, right?
Waste.
So we have short one, so we use the shorter one. You see it? Then we connect here, and then we can use another one. You can give me blue.
Small.
Yes, small. You see it? So now this is the just open circuit test. I'm coming. I want to go gradually. Why am I explaining this very seriously? First of all, it is one of the most important experiments in electrical engineering or in machines, because all of the power systems are interconnected, and this is the principle they use. This is number one. Because of that, we also make it very important in your final, everyone must pass through here. Everyone must be questioned about this. We have chauffeur here, we'll connect the circuit down, and you come and operate, we'll ask you questions. Right? Operate is synchronized. How do you increase reactive power, active power, make it to the motor, generator? Understand? This is why I'm spending the time. I'm giving you the exam as well as the questions, the answers. If you forget, it's your problem. Right?
Make it a motor instead of generator?
Yes, listen. So you get it. Now here, we have three main supplies. Three main supplies, 380. It comes from Skiko. This is Skiko. This is the switch. Is that okay? This is the switch. So look here. We want to create this switch, the one with the dot, right?
When synchronization complete.
Yeah. So I make this one to be
Switch.
My switch, like my infinite bus, where I will connect my Skiko, line 1 of Skiko to this one. That means line 1 corresponds to you, sir?
Yes.
Line 2 corresponds to
V.
and then line 3 corresponds to W. We are not going to connect the neutral, so we'll leave it that way for this one. Now, listen, before I start the connection, look at it. I have not yet connected. This is only a synchronous machine, sir. I can control the speed by what? By motor. So when I change this one, when it is too much, okay. So what do you see? When the machine is standing alone, I control this by this. When I change the speed, what will change? The frequency.
Yes.
Right? The frequency is the same like the speed. Now, if I want to generate voltage, what do I do? The
Field current.
The field current. When I increase the field current, I will increase the voltage. This is just the open circuit we did last week. Sir?
Yes.
Now we are going to connect this machine to Skiko here. But before we do that, we need 2 meters more, an ammeter, so that we monitor, we don't overload this. And then what? Watt meter.
Watt meter.
This watt meter, did you use it before?
Yes.
Okay, so we have what? P and Q, right? And we can set the voltage here, the current here, and we use this one and read this one. Okay.
Okay.
So now let's use what? Red. Let me use red. Okay, let me use. Okay, I'm using this my red as my beginning point. So this one will go to what? An ammeter, right? Ammeter O.
Oh.
Right? Then it will leave the ammeter to the watt meter, right? The watt meter is what?
Oh.
At the point of O, please, this is equals to half. You remember the other time, eh? Okay. Then at 3, we go to the
I.
We go to U.
U.
Yes. So I'm correct, right? So forget about this one. We go to U, sir. Then here U is the neutral. It goes to where? The common point. So let's use the black one.
U مرة ثانية من 5.
U is 5, sir. It goes to where?
Neutral.
Neutral. What does it mean? What does it mean? It means that this is reading power of what?
One phase.
One phase. Red phase. Because red and neutral. So red phase. If I want 3-phase power, I have to multiply by 3. Masala, if I ask you that, put 600 watts on this motor, it means this should read what? 200 watts. Right? Because it's single phase. Sir, if I ask you, make this motor machine deliver 600 watts, it means this should be read divide by 3. Right?
Yes.
Divide. Because if you multiply by 3, it will be. I said this machine is 3-phase. So when it is making this, but this one is connected what? Single phase. In the exam, this is what some of the students get confused. Right? This is a single phase. This is, so it will read only single phase power. So if I ask you to put 300 and you are forcing to make this 300, it means that when you make this 300, this now becomes what? 900. Right? So if I ask you to put 300, just put 100.
And if I connected this to another line, it will be the same.
No,
900, 900.
Huh?
Line to
It will
line.
be 3-phase power reading here.
No. Because this meter is designed to read only single phase. It's a single phase watt meter. We have another watt meter that can read single phase and 3-phase digital, but we don't want to use it. This is that okay? Because of the this. Now, is that okay? So then the second one is what? The second one is, let's take blue. Blue. If you feel that this is holding very well, so blue
Goes to V.
goes to V. And then we take the last one, yellow.
Go to W.
Yellow now goes to W. Have you seen it? Right? Do you get it?
Yes, okay.
Now let's look at it again. This is Kiko. This is my machine. They are both source of voltage. So if you make them to run together, there will be problems. For example, let me show you. This switch is very dangerous. Don't switch it on until this one. Look, remember how to switch this one on? Here, please, I want you to remember, in the exam, he will ask you to switch on. Some of you will come, you cannot switch on, or you even connect your circuit, you cannot switch on. We'll subtract max. This one, just look at this arrow. It's easy. It shows that. Just look. Right? And then here, 10 key switch clockwise. Key switch, look yamin, imsik ala yamin, summa idda ala hada. Right? Now we have Skiko up to this. The only thing different is this one. If I make mistake and I switch on Skiko, what happened? Look. You want to run, you see, you are going to destroy the whole system. because this is feeding voltage here. If you want it to run as a motor, then you connect it as a motor, then it will run as a motor. But don't use this switch until certain conditions are fulfilled. What are the conditions?
Synchronization, the voltage is the same,
Voltage.
frequency the same, phase sequence, phase angle.
Good. So these are the 4 conditions. This is why we are not doing the quiz today, so that next week when you are doing, you should remember everything, right?
Yes.
So we are giving you this. You should all get 5-5.
Inshallah.
Right? Inshallah. Okay. Now, how do I read the voltages? If I have a voltmeter here to read red and this, and I connect another voltmeter here, you remember this one will have error, and the other voltmeter will have error, sir? So it's good to use one instrument. And this instrument is here called what? Double frequency meter. Right? This and this are on the same instrument. So if there's error, it's the same error, so you can click. Right? So now let's say U1, which is V1, that is V1, U2, V2, voltmeter 1, voltmeter 2. We are going to connect this one for SCICO, because SCICO is already there, and we connect what?
Generator.
Generator to 2. We have double frequency meter also, which can read the frequency here and there. If we read the frequency, approximately we are reading the speed, right?
Yes.
Then we have here called synchronoscope. It is called synchronoscope or synchronoscope. This one is the one that shows us the phase angle why they should be equal for us to close. Usually it should be closed at 12, but we cannot just know because this is running.
When
We
it's
cannot know when it is going to. So there are some synchronizing panel of 3 lamps. Is that okay? We connect these 3 lamps in a way. For example, I can make all of them to be bright. I can connect it so that all of them will be bright here, or one will be bright and 2 dark, or all of them will be dark. Is that okay? In our book here, we made 1 bright and the 2 off. So if I know this is bright and this is supposed to be off, at 12 o'clock, when these ones are the same, it means what? The phase sequence is correct. This is giving us the phase sequence, this is giving us the angle. So if the phase sequence is correct at here, we'll close this.